Okay, so before we go much further, we need to be able to ask this question, what's going on with E? Because we've just introduced a bunch of decay equations which we've called exponential functions, where the charge on a capacitor drops down over time in an exponential way, and the current and the potential difference. And they have this E in there. And so, well, if you've done a whole load of maths, if you're strong in maths and studying maths, then hopefully you might not even need to do this section, or you might just want to review it quickly and check your kind of knowledge is good. If you're not doing maths, or you're a bit shaky about it, then this is going to be quite an important section just to kind of get clear on what you need to know about exponentials and logarithms when it comes to physics. Well, first up then, E is just a number like pi. So but instead of being 3.1415, it's 2.71828, on it goes. Well, so what I mean like pi is that it's irrational, it goes on forever. And it has a special significance in nature. And without going much more into that, because we just want to apply it to our physics, well, it's particularly important when you have a relationship between a quantity and the rate of change of that quantity. So like we've got, do you remember in the last video, we said that the charge on a capacitor is proportional to the rate of change of charge on the capacitor. And when you have that sort of relationship, E kind of crops up. It's a special number in those types of situations. Okay, so we've got to be able to deal with logarithms and exponential functions. So let's start with logarithms and see how they're connected to exponential functions in a minute. Well, there are two types of logarithms that you're going to have to deal with. And there's a normal logarithm, so-called, and a natural logarithm. So let's start with the normal ones. Well, the normal ones have nothing to do with E at all. And we just say that we define them in a certain particular way. And we actually say that we write it log of a number. So let's put the log of x. Well, what exactly does that mean? Well, when you see a log written like that, when there's nothing written down here, there's no little subscript number there, then it means that actually there is, but we're not bothering to write it, and it's a 10. And that's called the base of the log. But without getting too bogged down in all the terminology, the meaning is kind of straightforward. And it's very simply the log of x in base 10, and I'm going to actually rub out the 10 because normally these logs are written without anything there, if it's base 10. And so the log of a number x is just literally what you have to raise x to raise 10 to get x. Yeah? So in other words, let me give you a couple of examples. Well, for example, if I said, okay, so what's the log of 100? Question mark. Well, what we have to ask is, well, what do I have to raise 10 to in order to get 100? And of course, we know straight away, well, 10 squared is 100. So therefore, the log of 100 is 2. And that's all it means. It takes a bit of getting used to, but it's just the number you have to raise 10 to get the number that you're looking for the log for. Let's do another one. Or we could say, okay, well, what's the log of 10,000, for example? And, well, we say, okay, well, what do we need to raise 10 to get 10,000? And obviously it's 10 to the 4, because 10 to the 4 is 1 with 4 zeros. And so the log of 10,000 is 4. So that's how it works. So it's kind of straightforward when you look at it that way. It's just what you have to raise 10 to get the value is the log of that value. So the log of 100 is 2, the log of 10,000 is 4. Obviously it gets a bit weird, say for example, if I didn't have something which was a power of 10, so because it still has a log. So for example, if I said, well, what's the log of 500? Question mark. Well, that's a bit more tricky because I have to say, well, 10 to the something must be equal to 500, and I've got to find that something. Well, that's where you just grab your calculator, and you'll see that there's a key which just says log, and you just punch in log 500. And if you do that, you can try it right now, then hopefully on your screen will appear the number 2.69897 and ... on it goes. And then you can try, if you use, actually it's the shift of that log key usually on most calculators. If you try 10 raised to 2.69897, then you'll get 500 or something very close, because we're obviously going to have a bit of a rounding error there. Okay, so that's the basic idea. And but look, just one extra little thing here. If we have, if we see something like this, if we have the log of, say, 10 to the 6, and we say, you know, what's the log of 10 to the 6? Then it's just worth noting that that's kind of really, really simple, because going back to this, well, what do we have to raise 10 to get 10 to the 6? Well, obviously, it's 6, because 10 to the 6 is 10 to the 6. I'll say that again. So, well, the log of 10 to the 6, well, the log of a number is what you have to raise 10 to get it. So, well, it's pretty clear that we're going to have to raise 10 to the 6 to get 10 to the 6. So I hope that makes sense. And if you think about that a bit, or pause if you need to, but once that clicks, you'll see exactly what I'm saying. So I can just write it like this. Of course, I could have written here, I could have written 100 as 10 to the 2. So log of 10 to the 2 is 2. It's exactly the same. Okay, well that's cool. And it's then worth realising that, well, that's always going to be true. You know, if I said, what's the log of 10 to the p? Well, that's going to be p. If I said, well, what's going to be the log of 10 to the xyz? Well, that's going to be xyz, because that's the definition of a log, what you have to raise 10 to get it. So hopefully so far so good. Well, what we're now going to look at is what is meant by a natural logarithm. And this is where e comes into its own. Because instead of talking about logs in base 10, and remember I said that if there's no number there, there's basically a 10. Well, a natural logarithm is simply the log in base e, in the base 2.718. What does that mean? Well, what it means is simply that it's the number, not that you have to raise 10 to get x, but the number you have to raise e to get x. Yeah? Kind of makes sense. So, well, before we continue, one point we should just quickly make there is that instead of being written log e, is usually written as ln of x. So, in other words, we normally we replace log in base e is known as the natural log. So it's written ln. It's known as a natural, because of this kind of occurrence in nature of this wonderful number. So we're going to write it like ln. I'm going to say it like that from now on, ln x. Well, ln x, therefore, is what you have to raise e to get x. So we can start to sort of look at some similar types of examples. We can say, okay, so that means that the natural log, or the ln, of e to the 2, well, it's what we have to raise e to get e to the 2. So in the same way that we had to raise 10 to the 6 to get 10 to the 6, well, we have to raise e to the 2 to get e to the 2. So hopefully you can see that the natural log of e to the 2 is going to be 2. Or the natural log of e to the 4 is, I mean, it's not so simple now to put in numbers which are powers of e, because without, they would be crazy numbers. We could do it on a calculator. So I'm just going to put the powers, just write them like this, because we already know what's going on there. So the natural log of e to the 4 would be 4, and, the natural log of e to the p will be p. The natural log of e to the xyz, in the same way as before, will be xyz, because the natural log of a number is what you have to raise e to get it. So hopefully that feels pretty good. I mean, when we're working with natural logs and we have to actually find a value, well, that's where you go to your calculator. And for example, if I put natural log of 500, well, we've got to find out, what we would have to raise e to in order to get 500. Well, of course, that's not obvious at all, but we can use, nor was it with when we had the log of 500. Well, we can use our calculator, have a look, and you'll see that there's a nice key there which says ln, and you can just punch it in. And if you punch it in, you'll see that you get that the natural log of 500 is 6.21460, if I've read my notes there correctly, ... And that means that if I got my calculator and did shift of that key and did e to the 6.21460 ... well, we'll just put a few, then it would spit back 500. Right, so, well, that's just the first bit. So have a quick go at the quick check quiz, and then we'll move on. Okay, so good luck with that.